Alright. Okay, in this video what we're going to be doing is we're going to be looking at um, some additional thread information regarding um, how threads are dispatched in regards to the pool. Um, when we created threads in our module, our thread pool, we didn't add any thread start routine. So in the case that a start routine is not provided, um, in this M data structure here, this is what occurs. So M data, M thread, run. So we'll go into it. Well, it's up here. This is it right here. So in run, here's where it sets the. Excuse me, I'm way under the weather. Yeah, this is where it sets the buffer um, to actually display. You can see threadpool %s worker thread %i. When we look at it up here, like you see global worker thread 0, threadpool global worker thread 0. Makes sense. Coming down here, you can see a while 1. This is an infinite loop. Starts off there, concludes way down here. It uses a couple important things. Here's an atomic defetch and add. So this will atomically fetch this and subtract it by 1. The reason that would happen, here we go, it says if check for stop. This is a method internally. It basically just uses the thread platform abstraction to determine whether or not the thread has stopped. So if the stop thread is in fact stopped, it is subtracted from the number of threads atomically again, and the actual loop here exits. If that doesn't occur, if it's not stopped for whatever reason, what happens is the number of ready threads here is subtracted by 1. This is set to false. Here's a code block here to determine whether or not it should be re-enabled to true. So the way this works is that we have this variable mpool. You can see it's part of thread, mpool. Go back. If mpool m work item queue take next, meaning that there's a work item to be processed here. Sorry, I'm reading. Mark the number of threads ready, increase it by 1, and then run the process routine here. So the process routine is attached to every work item, I'm assuming. So this is an empty object. When the pool takes item into next, I'm guessing this is filled out. And basically this processes whatever work item we want. If not, it says wait for signal is true. So if it does signal, if there is something to process, I guess this is the signal handler kind of deal. This is where items are like literally processed via the signaling. If there is that, process it. If not, wait for signal is true. If wait for signal is true, set the number of threads awake -1 because we're going to be waiting. And here we're just going to get a semaphore and acquire it, which basically means wait for a work item. This is something that I said I was going to look at more in, I think, one of the first or second videos. I didn't completely understand what was going on, but now I get it. So this right here, it just waits for something to come through. Something does come through, goes through. It says number of threads awake, add. Number of threads ready, add, or add 1 to both. Then it continues back up the top and does it over. So now we have, what, 2 threads doing this right now? What we can do to understand this a little bit better, I guess, is to set a breakpoint here. So whenever our work item does come through, we can see how it's actually being handled. So let's continue. Continue, 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 continue. Continue. No, I don't know if you could hear the speech system thing. But continue. So we shouldn't actually have any data to process until we are in the application itself, I think. So we're just going to run right through. There's another thread started. Play, go. Okay. Here you can see we've got a work queue item, a work item. Let's see, M pointer. Hold on, sync read item. M packet. M format. Oh, it's for the sound effects. So this is processing sound effect stuff. So if we step over and then step into, step to return, step into, step, and execute here, async packet stream. So call parent execute. Packet size, looping, buffer the packet. So this is not very complex code, but pretty complex code. Something we're going to have to come back and analyze again later. So we're going to have to come back and analyze what we've already come back and analyzed. Interesting. Execute till return. Execute till return. So now if we step, just wait for signal. It's false. So it should skip over all of this and just go right back up to the top. There we go. Let's see if it signals again. Nope. So here you can see this thread is just out of stuff to do. Either that or it's not catching signals for whatever reason. But if I continue, threads ready is 0. Let's continue. What if we go step, step, threads ready is 0. See how it's subtracting and running over again. You can see we're in the sound effects worker threads right now. Should have looked at that earlier. So what we really need to do, I think, is to look at how items get into the work item queue. Because if we can figure that out, then we can start balancing our custom module work items within these queues. I think that would be the best way to do it. If you can just deliberately balance your work throughout the worker threads, I think that's just the smartest way to do it. Because it won't work unless it's necessary. I'm going to disable this. And I'm going to continue it. Cool. Look at the console. I want to see what the console looks like. Do. Hmm. What is this percent 1.2 index 14? Percent 1, what's that all about? Mm, okay, but yeah, that's it. Maybe in a different video, I'll look at how to actually supply the M data to set up custom thread run routines, like just in case I want to do it that way. I don't think I'll need to do it that way. If I can figure out how to like mess with this work item queue, I think I don't really even need to do that. I think I can just have, one thread that just constantly queues up work for the worker threads. Mm, that's it. Okay, I'm gonna stop the video. Thanks for listening, even if it's only me.